Hi, welcome to Math Antics. In our last geometry video, we learned that all two-dimensional shapes have a one-dimensional quantity called perimeter, which is basically the outline of the shape. In this video, we're going to learn that these shapes also have a two-dimensional quantity called area. To help you understand what area is, let's start by imagining a line that's 1 centimeter long. Now, let's imagine moving that line in a perpendicular direction a distance of 1 centimeter. But while we move it, it leaves a trail, almost like the end of a paintbrush. By moving the one-dimensional line that way, we formed a two-dimensional shape. And all of the space or surface that we covered along the way is the area of that shape, which as you can see here is just a square. Okay, but how much area does this square have? Well, our original line was 1 centimeter long, and we moved it a distance of 1 centimeter, so we could say that this shape is a square centimeter. Just like a centimeter is a basic unit for measuring length, a square centimeter is a basic unit for measuring area. But there's other units for area too. For example, instead of a centimeter, what if our line had been a meter long? And what if we had moved it 1 meter? The area we'd have gotten would be 1 square meter. Or what if our line was a mile long and we moved it a mile? We'd have a square mile of area. So just like with perimeter, the units of measurement are very important when we're talking about area. Alright, so that gives you a good idea of what area is, but how do we calculate area mathematically? Well, there's some special math formulas or equations that we can use to find the area of different shapes. In this video, we're going to learn the formula for squares and rectangles and the formula for triangles. To find the area of any square or rectangle, all we have to do is multiply its two side dimensions together. They're usually called the length and the width. So the formula looks like this. Area equals length times width. But it's often written with just the first letters of each word as abbreviations. A for area, L for length, and W for width. So let's see if that formula works for our original square centimeter. If we multiply the length, 1 centimeter, times the width, 1 centimeter, what do we get? Well, 1 times 1 is just 1, but what about centimeter times centimeter? Centimeter times centimeter just gives us square centimeters, which we can write like this using a 2 as an exponent. We read this as centimeters squared, and it's just a shorter way of writing centimeter times centimeter. So whenever you see units like centimeters squared, or inches squared, or meters squared, or miles squared, you know it's a measurement of the two-dimensional quantity area. Okay, our formula, area equals length times width, worked for our square. Now let's see if it works for a rectangle. Here's a rectangle that's 4 centimeters wide and 2 centimeters long or tall. First, we plug the length and width into our formula, 2 centimeters and 4 centimeters. Then we just multiply. 2 times 4 equals 8, and centimeter times centimeter is centimeter squared. So according to our formula, the area of this rectangle is 8 centimeters squared. And we can see that's correct if we bring back our original square centimeter. If we make copies of it, you can see that exactly 8 of those square centimeters would be the same area as this rectangle. Great. Let's try our formula on one more rectangle. This rectangle is 2 centimeters long, but only half a centimeter wide. And our formula, area equals length times width, tells us that we just need to multiply these two sides together to get our area. 2 times 1/2 equals 1. So this rectangle is also 1 square centimeter. How could that be a square centimeter? It's not even a square. But just because a shape takes up 1 square centimeter of area, that doesn't mean it has to be a square shape. It just means that the total area would be equal or the same as a square centimeter. You can see that if we break up the rectangle in half and rearrange it, then it would form a square. In fact, we can use square units, like square centimeters, to measure any area, no matter what the shape is. It could be a rectangle, a triangle, a circle, or any other two-dimensional shape.
Let's say that what we want to do is we want to find the area of this shape right here. Well, one thing we could do is we could just count squares. You could just say, okay, there's 1 square unit, 2 square units, 3 square units, 4 square units, and you could go down and you could count every single one of these squares and figure out how many square units there are. In fact, I'm going to encourage you to pause the video right now, count it, and just check to see if you're going to get the answers that we're going to be getting later in this video. I hope you got a good answer there. I changed the image here because, yeah, counting squares is great, but if there's a situation like this where there are no grid lines anywhere in here, we need some other ways of finding area. So I want to talk about 3 different ways of finding areas for figures like this. The first method is decomposing. Think zombies with their arms and legs falling off. And the idea is I want to take the shape that I have here and I want to somehow break it into pieces where each piece is something that I can easily find the area of. Here's one suggestion. I can start right here and draw a line right here like this. I want to separate this into 2 pieces. And the great thing now is I've got a rectangle and I've got a rectangle. What I have here is I've got on the left, this has a width of 4 and a height of 6. And on my smaller shape, I've got a width of 4 and a height of 4. So if I'm talking about finding area, I'm doing height times width. So 6 times 4 equals 24. And 4 times 4 equals 16. So over on the side, I need to take these 2 areas, the one here and the one here, and add up what I have. So I'm going to have 24 plus 16, and that happens to be 40. And let's put some units on there. I haven't told you how I'm measuring this, but let's say that we are measuring this in square units. I'm hoping that's the answer that you got before. This is the idea behind decomposing. When you decompose, you take a shape and you break it up into pieces where it's easy to find the area of each piece. Let's talk about subtracting instead. Whenever you're doing subtracting, you want to take something big and take away something from it to get the shape that you're interested in. So for example, what I can see here is that this shape, if I could draw this big box here, the shape is contained in this big box right here. And to get the shape, what I'm really doing is I'm taking the big box and taking away this piece right here. So if I think about what's going on, the big box, if I'm counting, so I'm counting the height and the width here, and the height of that box is 6, and the width of that box is 8. And again, when I find area, I'm going to be multiplying those 2 numbers. But now, what I'm going to do now is look at my small box that I'm taking away. I'm taking this piece away to leave everything that I want to find the area of. And that piece right there has got a height of 2 and a width of 4. And of course, 2 times 4 equals 8. And it's important that we're calling this subtracting, because now, to find my area, I'm going to take the 48 minus the 8, get 40, and say that that is 40 square units. Same answer. Yay, always good when we can get the same answer 2 different ways. The last way to get my answer is called rearranging, and it's a little bit like decomposition, except what I'm going to do is I'm going to move some pieces around. So if you notice, I already have this line drawn right here. And what I can say is I want to take this piece right here, which is 4 by 4, and I want to move it down here. So I'm just going to actually take that piece and I'm going to move it down here so that I'm going to have something that's going to be height 4 and width 4. And it's like this part no longer exists. I've gotten rid of all that stuff. Ooh, don't even look at it. It's gone. So now what I have is one big rectangle. And if it's time to find the dimensions of that rectangle, Then what I have is going across, I have 4 for the width. And if I'm counting up all the way here, then what I'm getting is a height of 10. So this is 10. Ooh, that looks like a very bad 10 there, but I hope you follow what's going on. And the width times the height is 4 times 10, and that's 40. Once again, 40 square units. So we had 3 different ways of finding the area of this shape. We talked about decomposing, breaking it up into 2 pieces, subtracting, big piece minus small piece, and finally rearranging, moving the shape around into something that we can work with.